Hello, my name is Daniel Ryan, and I'm going to be presenting the Automated Speech Recognition System for Childhood Language Development. Language development challenges in young children are quite common and can range anywhere from severe to very mild. In all cases, they're very frustrating, though, for the parents as well as the children themselves. So our goal here is to provide a fun interactive tool that helps improve those language skills. So we can imagine a young child speaking into a tablet. So as they utter words or word fragments, they're presented with images of potential matches. And then once they complete a word, they would get some positive feedback that they've spoken it correctly. We can imagine that this vocabulary set could be expandable also as their speech develops. So to accomplish this, we use the TensorFlow speech commands dataset. Consists of over 100,000 utterances of 35 words, each in about a 1 second clip. And similarly to what we did on the keyword detection programming assignment this semester, we generated a data set by overlaying randomly selected positive words and negative words onto a background signal. The model we developed here was a unidirectional recurrent neural network built on top of the Keras API. It was based off the trigger word detection programming assignment, as I mentioned earlier. However, it was now expanded to support multiple classifications. So, whereas in the original programming assignment, we were just worried about a single trigger word generating a trigger response. Here we now have 6 positive words in our data set that we would like to recognize. So to accomplish this, our final layer of our output was a softmax layer where we are presented a probability that each one of those words, including a unrecognized or no word, was found. Looking at some of our initial results here, so we see good accuracy on our training and dev sets. However, this is a little bit misleading because of the overwhelming amount of zeros in our output files here, so it's dominated by that response. So when we actually look at some of the files themselves, the outputs, we start to see some of the areas where we need to improve upon. So generally speaking, the words, the unrecognized, unknown words, it does a pretty good job of filtering out. It does occasionally identify our positive words, however, it very rarely correctly identifies them. So to improve upon these, we recommend expanding and diversifying the data set. So we had a very small number of negative words, for example, in a relatively small data set that we think we could improve upon. So in summary, our model does not perform well enough at this time to meet the project objectives, but we expect that it could be improved, as I mentioned, by expanding the data set. Finally, this presents a simpler alternative to many full language recognition models. So here we only need to recognize a small set of the English language. Thank you.